if you look for a complex number which is subject to the equation like this, it's a quadratic equation given that the highest coefficient is non-zero. Given this condition, it will be something we call quadratic equation. And we have a formulae for the solutions, which are like so. You knew this formulae in case of real numbers. They stand equally true when you look at complex numbers, and we're going to use them. In fact, I used them already 2 days ago when we discussed with you solution to, when we found with you the side of the perfect pentagon, we solved the quadratic equation on the way. I used that formula there. It is often more efficient. It's something I like a lot. It's something I used a lot. It is when you look at the equation where your b coefficient is even integer. In that case, there is a simpler formula which goes like this, where you halve everything across the formula. The formula itself looks longer, and it may look even more complex, but computationally it's an easier formula, especially when you try to guess the root in here. The number here will be lower, and that's a formula which I often use actually. I call it a half formula for the quadratic equation, and I use it often when b is even integer. The other thing which is often used in relation to quadratic equations is what is called the Vieta's theorem. Vieta's theorem, it specifically refers to unital quadratic equations. When I say unital, it means that the highest coefficient here is 1. In that case, it is often written like this. They change the name for the coefficients. They call it P and Q rather than B and C. It's just a convention. Many books do that, and I do it as well. Vieta's theorem says that if you're looking at this unital quadratic equation with the highest coefficient 1, then two solutions you will have for this equation. They will be subject to the relations like this. Some of them will be P, and the product will be Q. The importance of Vieta's theorem, there are lots of things which underlines the importance of the Vieta's theorem. For our purposes, it often enables us to guess the roots quickly, and it also sometimes enables us to convert back from the relation like this into the quadratic equation, something, in fact, I'm going to do very soon. Yes. So I have two examples of quadratic equations on this slide. One of them, absolutely elementary, is like this. 5x squared take 4x plus 1. It's a clear choice for the half formula, because the b coefficient here is even integer. So if you solve this equation according to by this formula, you can't use the Vieta's. If you solve this with the half formula, what's happening today? Is a solution to that. Half of b, or negative half of b from here, plus minus square of half of b, which is 4, and take AC. 4 take 5, it's negative 1, so it's imaginary unit, and that's the answer. It's a complex number, not necessarily. It's a complex solution. So even on this simple case, I think you can appreciate the efficiency of the half formula. It gives you lower numbers, which doesn't require any calculator.